Archaeornithoids. Archaeornithoids is a genus of maniraptoriform theropod dinosaur of the Late Cretaceous of Mongolia. Discovery and naming. In 1965, a Polish Mongolian paleontological expedition found a fossil of a small dinosaur at Bayansak, Mongolia. In 1983, the find was reported by Andrzej Elzanowski. The remains were named as the type species Archaeornithoides DINOSAURS by Elzanowski and Peter Welnhofer in 1992. In 1993, they were described in more detail by the same authors. The generic name, Archaeornithoides, means shaped like an ancient bird in ancient Greek, from rho chi alpha omicron sigma, archaeos, ancient, rho nu iota sigma, ornis, bird, and epsilon delta omicron sigma, aetos, form. The specific descriptor Dinosauriskis, little dinosaur, alludes to the animal's small size for a dinosaur. The holotype, Splem GD2/29, was discovered in late Cretaceous river sandstones of the Detector formation beds, dating from the late Campanian. It consists of an articulated but fragmentary skull and lower jaws comprehending paired maxillae, a partial eugle, palate bones and dentaries. The specimen represents a juvenile individual. Description. The holotype of Archaeornithoides was a very small individual. The head fragment as preserved measures just 27 mm in length, indicating an original skull length of about 5 cm. The body length was estimated at 50 to 60 cm, making the Archaeornithoides type one of the smallest known non-avian dinosaurs. Adult length is uncertain. The snout of Archaeornithoides features a long antorbital fenestra, stretching over 3/4 of the length of the maxilla. The maxilla bears at least 8 teeth. These are small, conical and smooth, lacking wrinkles, serrations or carinae. The palatine bone seems to show the presence of a secondary fenestra. Classification. Elzanowski and Welnhofer, 1993, claimed that Archaeornithoides was the closest known relative to birds or aviale. This conclusion rested on key bird-like features, an interdigitated suture between the premaxilla and maxilla, broad palatal shelves, pneumatic sinuses, lack of interdental plates, and unserrated teeth. Since publication, though, all of these features have been discovered in new fossils of adult and or juvenile troodonts and dromaeosaurs. The describing authors in 1993 also concluded that Archaeornithoides was closely related to troodontids, Spinosauridae and Lisbosaurus, all these taxa together with birds forming a clade, showing that birds originated from a more basal position than normally assumed. However, subsequent research has not supported a close relationship between Spinosaurids and troodontids, and Lisbosaurus was later shown to be a lizard or a crocodilomorph. Some scientists had suggested that the juvenile specimen of Archaeornithoides may belong to a previously known species of Mongolian troodontid, either Saurornithoides or Byronosaurus. However, studies of a juvenile Byronosaurus skull showed that theropod dinosaurs possess many distinctive adult characteristics even as hatchlings or embryos, and that the lack of characters solidly linking Archaeornithoides to known adult specimens shows that it is probably a distinct species. Bever and Norell, in 2009, found no evidence to support the placement of Archaeornithoides close to aviale, and only weak support for the idea that it is a juvenile troodontid. Possible predation by mammals. Elzanowski and Welnhofer noted that the specimen has distinct bite marks while the back of the head fragment was ragged, and suggested that the jaws were bitten off from its brain case by a deltatheridian mammal the size of a weasel, adding that these are common in the Bayansak assemblage. Clark and colleagues, 2002, noted that it may have also passed through the digestive tract of the predator before fossilization. If true, this may be the first known evidence of Mesozoic mammals feeding on dinosaurs. See Rapenamamus.